So good day viewers, welcome to another mathematics presentation. So in this presentation we are going to answer mathematics paper 1 for 2024. This is for external candidates. So this is our part 1. So make sure that you stay glued to the channel to take a look at part 2 that is going to be uploaded. Alright, so we now come to our question 1 right here. Evaluate. In brackets, we have 8 over 27 raised to the power 2 over 3. So, first thing, we are going to write our question, which is 8 over 27 raised to the power 2/3. Okay? So, this is that what you have. Now, this one, we are going to write it in this form. So, this is a base. So, this base is raised to the power of 2 over 3. So, since the power is a fraction form, so this 3 represents the root, okay? So we are going to say third root of the base. So our base is 8 over 27, okay? So this is how you present your work. And then you put everything in brackets, and this 2 becomes the what? The power like this. So from here, I will say the third root of 8 and the third root of 27. So these third roots are affecting both the numerator and the denominator. So the third root of 8, it's a 2, meaning that the number that will multiply by itself 3 times to get 8. Over the third root of 27 is a 3. Okay? Let's not forget the power 2, like this. So from here, 2 over 3 in brackets, raised to the power of 2 to give us 4 over 9. So this means 2 over 3 times 2 over 3. So 2 times 2, 4. 3 times 3, 9. So this is our answer, which was a 4 over 9. So we have answered our question 1. So if you don't want to use this method, there is another method that you can use to answer this question. So let's now take a look at question 2. Alright, so this is our question 2. Simplify. 4 in brackets we have x minus 2 plus 3 in brackets we have 2x minus 3. So I'm going to write our question, which is 4, then x minus 2 plus 3 in brackets we have 2x minus 3. So here we need to open the brackets. So to open these brackets, we are going to multiply with a 4. So 4 times x, we get 4x, minus 4 times 2, we'll get 8, plus 3 times 2x, we'll get 6x, positive times negative, we'll get a negative, 3 times 3 will get a 9. Then from here, we can correct the like terms. So 4x and plus 6x are like terms. So right, 4x plus 6x, then minus 9 minus 8. If you want, you can say minus 8 minus 9. So 4x plus 6x, this will give us 10x. Negative, negative, we maintain the same sign. So 9 plus this to give us negative 17. So negative 9 minus 8 to give us negative 17. So our answer, we have said, is 10x minus 17. So I hope it's clear. We now move on to our third question. Alright, so this is our third question. Solve the equation 3x minus 5 in brackets. Again here, x plus 2 in brackets equal to 0. So this is a quadratic equation, which is going to give us 2 possible values of x. So as you can see on the option, we even have that. So we can write 3x minus 5 in brackets, and then we have x plus 2 is equal to 0. So the first bracket will be equated to 0. Again, the second bracket will be equated to 0. So we are going to have 3x minus 5 is equal to 0, or we say x plus 2 is equal to 0. So we can now solve this equation. We also solve this one. So for this one, the negative 5 will go this side. So we are going to have 3x is equal to a 5. It will be a positive 5. So here we say, or this positive 2 go this side. So we are going to have x is equal to 0 minus 2. 0 minus 2, like this. Okay? So here we divide by 3. We also divide by 3. X is equal to 5 over 3. So this and this will cancel, or x is equal to 0 minus 2 to give us negative 2. So we can leave our final answer. We say x is equal to negative 2, or x is equal to 1, then 2 over 3. Alright, so I hope it's clear. So for this one, we have just said 3 into 5, it's a 1. 1 becomes a whole number. The remainder is 2, then over 3. So these are the values of what? Of x. Alright, so we now come to our question 4. Factorize completely 7x squared minus 7. So we are going to write our expression 7x squared minus 7. So to factorize completely this expression, we need to look at the numbers and the variables. So we have 7 and 7, then we have x squared. On this other term, there is no x. So we look for the highest common factor of 7, and this 7, it's 7. So we factor out 7. Alright, so we have factored out 7. So we can now say open bracket. So once we start dividing now, 7x squared, we divide by 7. This 7 and this 7 will cancel. We just remain with the x squared minus 7 into 7. It's a what? A 1. So this is what you get. Okay. So what you have been doing here is, after finding the highest common factor, we are just dividing, where you get 7x squared divided by 7. So you cancel this and this, we are remaining with this. This is what I've written here. The same thing has been done to this 7. We divided and we got a 1. Now, when you observe what we have inside the brackets, we have x squared minus 1. So x is squared, then this one is not squared, but it's a perfect square number. So because of the minus here, so we can have what we call the difference of two squares. So you write 7, open bracket, x squared minus 1 squared, because 1 squared will also give us 1. So here we can now say 7, open bracket, x minus 1, then x plus 1. Okay, so this will be our final answer. So this is our answer. So our final answer is 7, then we have this square bracket minus 1, then x plus 1. Okay, so we have factorized this expression. So we now move on to our question 5. Alright, so we now come to our question 5. Our question 5 reads, use set notation to describe the shaded region in the Venn diagram below. So this is the Venn diagram, which is comprised of 3 sets, set A, set B, and set C. So they want us to use a set notation to describe the shaded region, which is B and C. So here we can observe that for B and C, for these two sets to be shaded, find that the elements that were in B, they are also combined with the elements that were in C. Okay, then for this set A, it's completely unshaded, meaning that this is the complement. Okay, so no element of set A should be part of the solution set of the union set of B and C. So we are going to say A complement intersection, open bracket, B union C. So this is our answer. So for B and C, they were combined. It was a union. Okay. Then A was a complement. So no element of this set A was supposed to be part of the solution set of B union C. So that's why I've written A complement intersection, in brackets we have B union C. Right, so we've now come to our last question, which is our question 6. So the question reads, a businessman got 800 shares worthy 7,200 kwacha. What was the cost of each share? Okay, so here they want us to find the cost of each share. So in order to find the cost of each share, we are going to write 800 shares. So we have been told that 800 shares was costing how much? 7,200 kwacha. Now, what about the cost of one share? So for one share, the cost of one share, in this case, we don't know. So we just put X because we don't know the cost of one share. So what you are going to do is, we need to find the value of X, which is representing the cost of one share. And in order to do this, we are going to cross multiply. So I'll multiply 800 shares times X, of which we are going to get 800 shares slash X. okay, which will be equal to, then 1 share times 7,200 kwacha, we'll get 7,200 kwacha slash share. So in this case, we are not interested in these shares, so we'll cancel this share and this share, okay. Then we are going to divide, okay, both sides by 800, so that on the left hand side we just remain with x. So even here we divide by 800. Then from here we are going to cancel this 800 and this 800, remain with x equal to, then we can cancel the 2 zeros with these 2 zeros. So we have 72 kwacha over 8. So here it now becomes very easy. Just say x is equal to, so 8 into 72, because they are many times 9.00. So meaning that the cost of each share, so we just say therefore cost of each share was 9 kwacha. So this is our final answer. So thank you so much, everybody. We've come to the end of our presentation for part 1. So stay glued to the channel. You look out for your part 2. Bye bye.